What we are doing is developing a global flood risk model. The model basically produces an estimate of flooding. By the estimate of flooding, I'm telling you that to what extent the flood will go, how high the flood will be. Simple as that. And data is the key part of it. Most of the data we use are geospatial data. So, it could be the elevation of the world. It's the river depth. And then we also need the land use types. It's a building footprint or it's a wetland. So these are the informations we need. And then we also need propagation of tide, sea level, storms. So, that's different data source that we use.
We use some global data on waves and extreme sea levels. And then we downscale those to local coastal areas across the state of California. And then we reconstruct both historic and future information on what's the climate. And we use that as input conditions to our models to derive ocean hazard maps to understand which areas could be flooded, which shorelines could be eroded under certain probabilities or storm conditions. And then we translate that to impacts and solutions.
What it does is basically it mimics the natural process. Instead of modeling a real event, we are saying that, all right, Hurricane Sandy is probably a 50-year event, which means it can happen once in a 50-year. So then we say that let's see how the flooding will be, for one in a 10-year event, one in a 25-year event, one in a 50-year event, one in a 100-year event, and then what the flooding would look like in different areas for these different statistical events. Because that gives you an idea or a range of what may happen. Because we cannot predict the future, but we can have an estimate of how the future may look like, so we can decide how we want our future to be.
That means that we need relatively complex tools, and it needs to combine different data sets, but also a lot of computing power to provide very granular results, and that needs to be informed with the input from the communities. So understanding the needs of the local community are very important to our analysis, to understand not only what are the risks, but also what could be the solutions.
And the model is very important here because with the model we can, create these scenarios like, okay, instead of levee, if we have, riprap, or if we have living shoreline, or if we have a combination of different flood structures, how the flooding will be reduced or how well we can protect our communities. In order for us to, I would say, sustainably and smartly utilize and apply our resources to tackle this problem, we need quantified approach. We need the data that can give us, sort of a straightforward answer.